25 coolest car inventions you probably didn't know existed. The automotive industry has always been a proving ground for mechanical ingenuity, materials science innovation, and increasingly digital intelligence. While most drivers are familiar with mainstream upgrades like infotainment systems, adaptive cruise control, and hybrid drivetrains, there's an entire ecosystem of lesser-known automotive inventions that dramatically improve convenience, safety, efficiency, and versatility. From high-density robotic parking towers to portable atmospheric water generators, from hydraulic van lifts to smart OBD telematics modules, these inventions demonstrate how interdisciplinary engineering, mechanical, electrical, structural, and software, continues to reshape how we use vehicles in daily life. Below is a comprehensive exploration of 25 of the coolest automotive inventions you likely didn't know about, reimagined, clarified, and expanded in detailed US English. 1. WOHR parking systems, high-density mechanical and robotic parking. Urban congestion is not just a traffic problem, it's a spatial problem. Land in cities is expensive, and traditional surface parking lots are incredibly inefficient. That's where WOHR parking systems steps in with advanced mechanical and automated parking solutions designed to multiply available parking capacity without expanding a building's footprint. Mechanical stackers. The simplest system is the mechanical stacker. Imagine a vertically oriented vehicle lift that allows 2 or 3 cars to be parked in the vertical space normally used by one. These systems are ideal for residential garages, small commercial buildings, and retrofit projects because they don't require major structural changes. Drivers park their vehicles independently, and the lift platform raises one car above another. Weight capacities typically range between approximately 4,400 and 6,600 pounds, making them suitable for most passenger vehicles and SUVs. Semi-automated grid systems. More advanced configurations, such as Combi-Lift and Combi-Parker systems, introduce multi-directional movement. Vehicles can be shifted up, down, and sideways, enabling dense grid-style parking layouts across multiple levels. These systems optimize both vertical and horizontal space utilization. Some models integrate EV charging stations, smartphone app control, remote activation systems, multi-level stacking 3 to 5 levels, fully automated robotic parking towers. At the highest tier, fully automated systems eliminate driver maneuvering entirely. The driver simply enters a transfer cabin, exits the vehicle, and the system autonomously moves the car into a robotic storage rack. These automated towers can extend up to 50 levels vertically. The system uses elevators, shuttles, and pallet carriers to place vehicles precisely into storage bays. This approach significantly reduces required ramp space, internal circulation lanes, vehicle emissions within the structure. In dense cities, robotic parking isn't futuristic, it's a spatial necessity. 2. RUBBIT'S waterless car wash in a can. Traditional car washing requires hoses, runoff management, buckets, and significant water consumption. RUBBIT introduces a different concept. A pressurized spray can containing a high lubricity cleaning foam engineered to encapsulate dirt particles without scratching paint. How it works. The foam lifts dirt, dust, sap, and bird droppings, encapsulates debris particles, allows safe wipe-off using microfiber towels. Each can typically supports multiple touch-ups, 2 to 3 full exterior cleanings. Aerospace origins. Interestingly, the formula originated in aviation. Small aircraft stored in hangars required waterless cleaning solutions to prevent puddling near sensitive avionics and wiring systems. The foam-based encapsulation technique proved effective, and it was later adapted for automotive paint systems. Benefits. No water runoff. Safe for clear coat finishes. Minimal streaking. Compact storage. 2-pack pricing starts around $35, making it an accessible alternative to traditional washing methods. 3. LEYOUTIME vehicle-to-load power for Tesla models. Electric vehicles are essentially large battery banks on wheels. LEYOUTIME transforms compatible Tesla vehicles into portable power stations. Compatible with CSS-enabled Tesla models such as the Model 3 and Model Y, the system provides 2 AC outlets delivering up to 5 kW combined output. Safety architecture. The system includes Automatic shutoff at 10% battery capacity. Overload protection. Overheating protection. Short circuit detection. Undervoltage protection. Lightning surge resistance. Water intrusion shutoff. Insulation exceeding 20 megohms. Use cases. Charging other EVs. Running power tools at job sites. Emergency home backup power. Camping equipment operation. Starting price approximately $399. For TOPLIFT Pro's one-person hardtop removal system. Jeep hardtops are notoriously heavy and awkward to remove. TOPLIFT Pros engineered a mechanical lift system that allows a single person to safely remove and store a hardtop without assistance. Compatible primarily with the Jeep Wrangler and adaptable to certain Gladiator and Bronco models, the system uses tubular steel frame construction. Adjustable lift range approximately 63-75 inches. Reinforced caster wheels 2 locking. Controlled gear-driven lifting mechanism. Unlike overhead hoist systems, this unit supports the hardtop from below, stabilizing it during removal. The hardtop can then be stored elevated above the hood, conserving garage space. Pricing begins around $880. 5 Space Campers Tesla Cybertruck conversion. The Tesla Cybertruck introduces unconventional geometry, and Space Campers complements it with a modular camper conversion system. System components. Pop-up wedge roof. Cargo cap enclosure. Integrated mattress 4-inch memory foam. Direct electrical integration. 110V outlets and USB ports. Modular rail system for shelving. Interior specifications. 8-foot ceiling height on one side. 6-foot height on the other. Electric pop-up roof deployment. Rear hatch synchronized with keyless locking. Setup and takedown take under 5 minutes via electric controls. 6 RoadMate 9-in-1 emergency kit. RoadMate consolidates 9 essential roadside tools into one system. Jump starter. Tire inflator 3036 SI until 2 minutes. 800 lumen multimode light. Portable pressure washer 6 spray angles. Foam cannon. 120 watt vacuum with dual filtration. 15,000 mAh power bank. 7W Bluetooth speaker 40-hour playback. 15W wireless charger. Retail price approximately $199. 7 CARGENTA Brain 2 OBD2 Smart Vehicle Monitor. Since 1996, most vehicles have included OBD2 ports. CARGENTA Brain 2 leverages this interface to extract real-time vehicle diagnostics. Data captured. Engine RPM. Coolant temperature. Battery voltage. Throttle position. Fuel consumption. Ignition timing. Fault codes. Integrated GPS allows trip playback with timestamps and route mapping. With Bluetooth and built-in SIM connectivity, users can monitor vehicles remotely. Approximate cost $299. 8 in the ditch registered speed dolly fender. Towing vehicles on dollies exposes them to debris impact. This fender system shields wheels and undercarriages during transport. Available in steel or aluminum, the fenders attach via pins and hardware to compatible dollies. They reduce paint and mechanical damage risk during highway towing. 9 TRAMONTINA Pro industrial-grade tool systems. Professional automotive and industrial technicians require durable tools. TRAMONTINA Pro tools use chrome vanadium and chrome molybdenum steel alloys for enhanced strength and torque tolerance. The product line includes insulated electrical tools meeting international standards, modular tool storage cabinets, mobile workstations, lockable chests, on-site transport bags. Each insulated tool includes traceable safety certification numbers. 10 RUBICON Dog Travel Crate. Manufactured in Minnesota, this open-top crate offers a safer backseat environment for dogs. Constructed from thick double-wall plastic, it prevents footwell sliding, allows airflow and visibility, fits most four-door vehicles, accommodates medium to large dogs. Interior dimensions, inches long, 17 inches wide. Retail price, approximately $700. 11 DEWEZE flatbed systems. The DEWEZE steel flatbeds incorporate Gator Hide anti-slip coating, steel headache racks, LED lighting systems, gooseneck hitch ratings up to 40,000 pounds, steering tie-downs, hydraulic system compatibility. Weight ranges between 1,100 and 1,760 pounds depending on configuration. 12. WATERGEN drinking water from air. WATERGEN's atmospheric water generators extract humidity from air through controlled condensation and filtration. Output range: residential units ~8 gallons per day. Industrial units up to 1,585 gallons per day. Energy consumption: approximately 400 Wh per liter. Industrial systems up to 60-90 kW draw. Filtration process: sediment filtration, carbon filtration, ultrafiltration membranes, UV sterilization, nanofiltration, mineral rebalancing, calcium and magnesium. Water temperature output ranges: cold degrees F, hot 185-203 degrees F. 13. Teletrac Navman Telematics. Teletrac Navman offers fleet telematics that monitor GPS location, driver behavior, hard braking, rapid acceleration, engine diagnostics, 4G data transmission. Battery-powered devices allow tracking of non-powered trailers. 14. RAZERLIFT motorized roof cargo lift. RAZERLIFT lowers roof cargo platforms to chest height for safe loading. Specifications: 150-pound capacity, electric motor with remote control, safety sensors, aluminum construction, installation between roof rails. 15. Snow Joe SJBLZD-LED. This winter tool combines 18-inch snow broom, ice scraper, LED illumination, extendable handle 33-52 inches, lightweight 1.5 pounds and priced around $30. 16. ECOJUMP. ECOXGEAR ECOJUMP provides 600 amp peak output, jumpstart capacity up to 6L engines, 5,000 mAh lithium battery, USB charging ports, 200 lumen flashlight, reverse polarity protection. Price approximately $140. 17. Bar VANLIFT hydraulic cargo platform. Compatible with vans such as the Mercedes-Benz Sprinter and Ford Transit, this hydraulic lift lifts up to 1,320 pounds. Uses aluminum anti-slip platforms. Includes safety sensors. Offers foldable or fixed configurations. 18. Car trash bag holder. A minimalist aluminum cylinder that stores roll-out waste bags. Specifications: 1.5-inch diameter, 10.5-inch length. Holds 22-pound capacity bags. Dashboard or headrest mounting. Cost $25. 19. AC tent, Tesla compatible climate tent. Designed for Tesla vehicles, the AC tent connects to camp mode airflow, allowing climate-controlled camping without engine operation. Features: 6-person capacity, rapid pop-up design, weather-sealed seams, secure trunk connection. 20. Tailgater ultralight cargo trailer. A 60 cubic foot lightweight plastic cargo trailer that doubles as a tailgating station. Includes foam core cooler insert, cutting board, utensil storage, beverage holders, gas grill. Retail price approximately $1,300. 21. Bike ERACK motorized hitch lift. Electric bike lifting system. Capacity 9,325 pounds. Wheelbase support, no frame clamping. Wireless remote. 7-pin trailer connector integration. 22. WINDSTORM starter multifunction emergency device. Combines: jump starter 16,000 mAh, 160 FT/S fan, high power vacuums, device charger, integrated lighting. Price $79. 23. Ute universal tailgate ladder. Foldable or rotating ladder attachment for truck beds. Specifications: 38-40 inches height, 440-pound capacity, 360 degrees rotating option. 24. SIDEPULLER towing system. Hydraulically stabilized boom system for angled recoveries. Winch ratings 9,000 20,000 pounds. Cable lengths up to 150 feet. Hydraulic stabilizing legs. Swiveling boom head. Ideal for ditch recovery and off-axis pulls. 25 TOWBAR hitch receiver systems. TOWBAR receivers enable trailer towing and hitch-mounted accessories. 2 primary types. Universal adjustable ball mounts 2-inch receivers, 5,000-pound capacity. Vehicle-specific bolt-on systems for trucks like the Toyota Hilux N80. Height-adjustable ball mounts allow proper trailer leveling, improving safety and load distribution. Final thoughts. These 25 automotive inventions illustrate how innovation extends far beyond engines and dashboards. Whether it's robotic parking towers solving urban density, atmospheric water generators extracting potable water from humidity, or hydraulic van lifts improving logistics efficiency, each invention addresses a real-world friction point in vehicle ownership or commercial transport. Modern vehicles are no longer just transportation devices, they are mobile power stations, data platforms, modular living spaces, industrial work tools, emergency preparedness hubs. As automotive engineering continues to intersect with energy storage, software systems, structural mechanics, and sustainability technologies, we can expect even more transformative inventions in the years ahead. The future of mobility is not only about driving, it's about capability. Continue and complete the remaining sections in the same depth. Below are the expanded and fully developed remaining sections, continuing in the same analytical depth, technical clarity, and structured format. 26. Advanced Vehicle Telematics and AI Fleet Optimization Platforms. While earlier telematics systems focused primarily on GPS tracking and basic driver behavior monitoring, next-generation AI-driven fleet optimization platforms take data aggregation much further. Systems like those offered by Teletrac Navman integrate multi-layered vehicle analytics with machine learning algorithms to optimize operational efficiency. Core system architecture. Modern telematics platforms typically consist of OBD-I or CAN bus connected vehicle interface modules, GPS positioning hardware, accelerometers and gyroscopes, cloud-based analytics engines, mobile and web-based dashboards. Data transmission occurs over 4G LTE or emerging 5G networks, enabling near real-time telemetry. Performance monitoring capabilities. Advanced systems can monitor engine load percentage, idle duration trends, fuel burn efficiency curves, transmission shift patterns, maintenance interval forecasting, tire pressure trends with TPMS integration. AI-based analytics evaluate driver behavior patterns over time, for example, excessive throttle input frequency, cornering G-force thresholds, repeated harsh braking, lane deviation camera-assisted systems, predictive maintenance. Machine learning models analyze historical engine performance data to detect early indicators of component failure. Instead of reactive maintenance, fleets transition to predictive service scheduling, minimizing downtime. For large logistics fleets, these systems can reduce fuel costs by 10–15% and significantly lower accident rates. 27. Modular overland recovery boards with integrated jack points. Off-road travel introduces unique recovery challenges. Traditional traction boards assist vehicles stuck in sand, mud, or snow, but newer modular recovery boards incorporate reinforced jack lift zones. These hybrid systems allow traction assistance, high lift jack stabilization, vehicle leveling support, structural engineering. Premium boards are manufactured from fiber-reinforced nylon composites, UV-stabilized thermoplastics, glass-filled polymers. Integrated structural ribs distribute vertical load forces when used as a jack base, preventing material deformation. Load ratings. Some models support vertical loads exceeding 10,000 pounds. Temperature tolerance from -40 degrees F to 140 degrees F. For overlanders traveling in remote terrain, combining traction and lifting capability reduces the need to carry separate heavy steel plates. 28. Smart tire monitoring and inflation systems. Tire pressure directly impacts fuel efficiency, tire wear patterns, braking distance, hydroplaning risk. Modern smart tire systems go beyond traditional dashboard TPMS alerts. External and internal sensor-based systems now provide real-time pressure readings, temperature monitoring, leak rate detection, automatic inflation adjustments, integrated air management. Some aftermarket kits include onboard air compressors tied into digital control modules. If pressure drops below a preset threshold, the system can automatically reinflate tires while driving at low speeds. This is particularly useful for off-road vehicles adjusting pressure for terrain, commercial fleets managing heavy payloads, long-distance towing operations. Digital readouts are accessible through smartphone apps with Bluetooth connectivity. 29. Portable lithium power stations for vehicles. While jump starters provide emergency engine ignition, modern lithium power stations serve as full auxiliary energy systems. Electrical specifications. High-capacity units provide 502,000 WH storage capacity, pure sine wave AC output, 12V DC regulated output, USB-C PD fast charging ports. These systems recharge via vehicle alternator, solar panels, shore power. When paired with EVs or large trucks, portable power stations act as redundant emergency systems. Applications include mobile offices, film production lighting, overlanding refrigeration, emergency disaster response. Lithium iron phosphate LiFePO4 chemistry increases cycle life to over 3,000 charge cycles compared to traditional lithium-ion packs. 30. Adjustable air suspension conversion kits. Air suspension was once exclusive to luxury vehicles. Today, modular air conversion kits allow drivers to retrofit adjustable ride height systems into trucks, vans, and SUVs. System components. Air springs replacing coil or leaf springs. Compressor unit. Air tank reservoir. Electronic control module. Height sensors. Functional advantages. Drivers can lower vehicles for highway aerodynamics, raise suspension for off-road clearance, level heavy payloads automatically, improve ride comfort under varying load conditions. Advanced kits allow preset ride height profiles stored in digital memory. Load leveling systems significantly reduce rear sag during towing, improving steering stability and braking performance. 31. Integrated vehicle solar roof panels. With the growing shift toward electrification, solar integration into vehicle rooftops is gaining traction. Though solar panels cannot fully power a vehicle independently, they can maintain auxiliary battery charge, power ventilation systems, offset parasitic drain, thin-film photovoltaic cells embedded into roof racks or directly into body panels are increasingly durable and flexible. In camper builds, solar roofs paired with lithium batteries allow complete off-grid functionality. 32. Smart rearview mirror dash cameras. Traditional dash cams record forward-facing footage. Smart mirror-integrated systems combine front and rear 4K cameras, blind spot visibility enhancement, parking surveillance mode, G-sensor collision recording. Instead of reflecting rear window obstruction, digital mirrors display wide-angle live camera feeds, improving visibility in cargo vans or trucks carrying loads. Cloud backup integration ensures footage preservation in the event of theft or collision. 33. Multi-stage vehicle water filtration and storage systems. For overland travelers and remote workers, onboard potable water systems have evolved beyond simple tanks. Advanced systems integrate sediment filtration, activated carbon, UV sterilization, reverse osmosis membranes. These can connect to portable generators like those from WATERGEN, allowing self-sufficient hydration solutions. Vehicles converted for expedition travel often carry 10-40 gallons of filtered water with pressurized pump systems. 34. Smart hitch alignment cameras. Backing up precisely to align a tow hitch with a trailer coupler can be frustrating. Smart hitch camera systems mount near the rear bumper and provide zoomed hitch alignment views, dynamic guiding lines, distance measurement overlays, Some systems integrate with factory infotainment screens, reducing coupling time significantly. Advanced sensors can detect trailer tongue weight distribution once connected. 35. Heated windshield wiper systems. Cold climates introduce frozen wipers and reduced visibility. Heated wiper systems use embedded resistive heating elements, heated washer fluid reservoirs, de-icing windshield base panels. These systems prevent ice accumulation at the base of windshields, improving winter safety. 36. Digital torque wrench systems. Precision torque application is critical in automotive repair. Digital torque wrenches now feature LCD torque displays, audible torque alerts, data logging capability, Bluetooth synchronization. These are especially valuable in cylinder head installation, suspension component replacement, wheel lug torque verification. Recorded torque values can be stored for compliance documentation in professional environments. 37. Smart vehicle fire suppression systems. Vehicle fires can escalate rapidly. Compact fire suppression modules designed for engine bays deploy automatically when heat thresholds are exceeded. These systems use clean agent fire suppression chemicals, heat-sensitive trigger lines, manual override switches. Primarily used in motorsports, they are increasingly installed in high-performance street vehicles. 38. Modular rooftop tents with integrated insulation. Rooftop tents have evolved with insulated thermal liners, integrated LED lighting, gas strut-assisted deployment, aluminum honeycomb base panels. These systems provide improved comfort in extreme climates and reduce setup time to under 60 seconds. 39. Electronic trailer brake controllers with adaptive algorithms. Modern electronic brake controllers detect deceleration rate, trailer weight, road incline. Adaptive systems automatically adjust braking force to prevent trailer sway. When paired with heavy-duty trucks such as the Toyota Hilux N80, electronic controllers significantly improve towing safety. 40. Intelligent cabin air purification systems. Cabin air quality impacts driver alertness. Advanced systems incorporate HEPA filtration, activated carbon odor absorption, PM2.5 detection sensors, automatic recirculation mode activation. Some vehicles now monitor external pollution levels and automatically seal the cabin when air quality deteriorates. Comprehensive closing perspective. The automotive ecosystem has evolved into a multidisciplinary engineering landscape combining mechanical systems, electrical distribution architecture, embedded software, cloud-based analytics, sustainable energy integration, human-centered ergonomic design. From robotic parking towers by WOHR parking systems to atmospheric water extraction solutions from WATERGEN, innovation now spans urban infrastructure, environmental sustainability, mobility intelligence, and emergency preparedness. Vehicles are no longer passive transportation devices. They function as energy storage platforms, remote data nodes, mobile living quarters, commercial productivity tools, safety command centers. The next decade will likely see deeper integration between electric vehicle battery systems, bidirectional power transfer, AI-based diagnostics, and modular mobility hardware. Automotive innovation is no longer incremental, it is systemic. And the most fascinating inventions are often the ones drivers never realized existed. Continue and complete the remaining sections in the same depth. Continuing in the same technical depth and structured analytical format, the following sections expand the landscape of advanced automotive inventions, focusing on emerging technologies, specialty hardware, and next-generation mobility enhancements that are reshaping how vehicles function in professional, recreational, and urban environments. 41. Vehicle-to-home V2H bidirectional charging systems. Electric vehicles are increasingly capable of operating as distributed energy storage units. Vehicle-to-home systems allow EV batteries to supply electricity back into residential electrical panels during outages or peak demand periods. System architecture. A complete V2H configuration includes bidirectional inverter, smart transfer switch, Home energy management system. Compatible EV with bidirectional charging capability. Certain electric vehicles already support limited vehicle-to-load functions, and future updates may expand full home integration. For example, the Tesla Model Y includes significant onboard battery capacity that, in theory, could power essential home circuits for multiple days if paired with appropriate hardware. Operational advantages. Backup power during outages. Peak shaving to reduce utility costs. Grid stabilization support. Emergency resilience. As renewable energy adoption grows, EV batteries may serve as decentralized microgrid assets. 42. Smart digital rear axle lockers. Off-road vehicles benefit from differential locking systems to ensure power delivery to both wheels on an axle. Traditional mechanical lockers require manual engagement. Smart electronic axle lockers integrate with traction control systems for automatic torque distribution. Engineering characteristics. Electronically controlled engagement. Wheel speed sensor feedback. On-demand locking based on slip detection. Integrated dashboard monitoring. These systems improve traction in mud, snow, sand, rock crawling scenarios. Modern locking differentials are common in high-performance off-road vehicles like the Jeep Wrangler Rubicon, but aftermarket retrofit kits now bring similar capability to other trucks and SUVs. 43. Portable EV fast-charging trailers. As electric vehicle adoption increases, infrastructure gaps remain in remote areas. Mobile DC fast-charging trailers provide temporary high-capacity charging stations. Technical specifications. Integrated lithium battery banks. DC fast charge output up to 150 kW on some models. Solar augmentation capability. Generator-assisted recharge backup. These systems are used for emergency roadside assistance, fleet charging and remote job sites, temporary event installations. They reduce reliance on fixed charging infrastructure and improve EV flexibility. 44. Advanced Driver Monitoring Systems, DMS. Driver fatigue and distraction contribute significantly to traffic incidents. Modern driver monitoring systems use infrared cameras, eye tracking software, facial recognition algorithms, steering input analysis, behavioral detection capabilities. Systems can detect drowsiness, blink rate, eye closure duration, smartphone distraction, head position anomalies, microsleep episodes. Alerts may escalate from visual warnings to audible signals and steering wheel vibration. Fleet telematics providers increasingly integrate DMS into commercial vehicle platforms. 45. Smart trailer sway mitigation systems. Trailer sway occurs when lateral oscillation destabilizes towing vehicles. Intelligent sway mitigation integrates yaw rate sensors, brake modulation control, trailer brake synchronization, steering correction assistance. When instability is detected, braking force is selectively applied to restore alignment. Heavy-duty trucks such as the Ford F-350 Super Duty incorporate integrated sway control systems to improve safety under high-load conditions. 46. Integrated dash-mounted heads-up display HUD retrofits. While premium vehicles often include factory-installed heads-up displays, aftermarket HUD systems project. Speed, RPM, navigation prompts, blind spot alerts. Projection methods include windshield reflective film, dedicated transparent combiner screens. Advanced units connect via OBD-I or GPS for real-time speed calibration. HUD systems improve situational awareness by minimizing downward eye movement. 47. Thermal imaging night vision for vehicles. Automotive night vision systems utilize forward-mounted infrared cameras to detect heat signatures beyond headlight range. Capabilities: pedestrian detection, animal detection, obstacle identification in low visibility. Thermal imaging displays typically appear in digital instrument clusters, infotainment screens. Though once exclusive to luxury vehicles, aftermarket modules now provide similar functionality for SUVs and trucks used in rural environments. 48. Smart modular drawer systems for overlanding. Vehicle cargo organization has evolved into modular aluminum drawer platforms designed for secure storage, slide-out kitchen integration, lockable compartments, fridge mounting rails. These systems are constructed from powder-coated aluminum, stainless steel hardware, ball-bearing drawer slides. Load ratings often exceed 200-500 pounds per drawer. In vehicles like the Toyota Land Cruiser, modular storage dramatically increases expedition efficiency. 49. Onboard air compressor and pneumatic systems. Integrated onboard air systems allow vehicles to power tire inflation, air tools, suspension systems. High-output compressors deliver 150-200 psi, rapid tire inflation, continuous duty cycles. Off-road vehicles often mount compressors under the hood or within cargo compartments. Air tank reservoirs improve burst output for tool usage. 50. Intelligent vehicle data recorders black box systems. Beyond consumer dash cams, professional-grade event data recorders capture throttle position, brake application, steering angle, airbag deployment metrics, impact g-forces. These systems assist in accident reconstruction, insurance investigations, fleet liability protection. Data encryption ensures tamper resistance. 51. Portable hydrogen fuel cell range extenders. Emerging hydrogen-based range extenders supplement EV battery packs using compact fuel cell generators. Functional principles. Hydrogen cartridge feeds fuel cell stack. Electricity generated recharges EV battery. Water vapor emitted is byproduct. Though not yet mainstream, modular hydrogen units may serve remote expedition travel, emergency energy augmentation. Hydrogen storage and infrastructure remain developmental challenges. 52. Smart keyless entry biometric systems. Traditional key fobs are vulnerable to signal relay attacks. Biometric systems introduce fingerprint recognition, facial authentication, encrypted smartphone proximity access. These systems reduce theft vulnerability and eliminate physical key dependence. Some vehicles now integrate facial recognition cameras into B-pillars for secure entry. 53. Digital mirror replacement systems. Side mirrors contribute aerodynamic drag. Digital mirror systems replace traditional mirrors with exterior cameras, interior display screens, blind spot overlays. Benefits include reduced drag coefficient, improved visibility in rain, enhanced night clarity. Commercial trucks increasingly adopt this technology for efficiency gains. 54. AI-based predictive traffic route optimization. Navigation systems now leverage cloud-based AI models to predict traffic congestion before it forms. Instead of reacting to traffic, predictive routing considers historical congestion patterns, event-based traffic spikes, weather disruptions, construction schedules. Advanced systems update routes dynamically with minimal latency. 55. Smart vehicle security perimeter systems. Perimeter security systems use 360 degrees camera arrays, ultrasonic proximity detection, motion-triggered recording, cloud notifications. When suspicious activity is detected, owners receive smartphone alerts with live video feeds. These systems extend traditional alarm functionality into surveillance-grade security. Strategic outlook on automotive innovation. Across mechanical systems, electrical infrastructure, digital analytics, and renewable energy integration, automotive innovation continues accelerating in complexity and capability. Key trends shaping the future include electrification and energy integration, bidirectional charging, mobile fast charging infrastructure, solar augmentation, intelligence and data, AI-driven telematics, driver monitoring systems, predictive maintenance, safety and resilience, thermal imaging detection, fire suppression systems, trailer sway stabilization, modularity and utility, camper conversions, hydraulic lift systems, modular cargo platforms. Vehicles increasingly function as distributed energy assets, Data collection nodes. Mobile command centers. Multi-environment living systems. The evolution from mechanical transportation devices to integrated mobility platforms is well underway. As battery technology improves, AI algorithms mature, and materials science advances, future automotive inventions will likely blur the lines between transportation, infrastructure, and personal energy ecosystems. The coolest car inventions are no longer optional accessories. They are indicators of a mobility transformation that is fundamentally redefining what vehicles can do. Continue and complete the remaining sections in the same depth. Continuing in the same structured, technical, and analytical depth, the following sections expand further into emerging automotive systems, advanced materials, and next-generation vehicle integration technologies that are reshaping mobility ecosystems across consumer, commercial, and industrial domains. 56. Solid-state battery integration platforms. One of the most transformative automotive developments on the horizon is the shift from conventional lithium-ion batteries to solid-state battery systems. Core engineering difference. Traditional lithium-ion batteries use liquid electrolytes. Solid-state batteries replace that liquid with a solid electrolyte material, which offers higher energy density, reduced fire risk, faster charging capability, longer cycle life. Performance advantages. Projected benefits include 30–50% increased range, charging times under 15 minutes for substantial capacity, lower thermal runaway risk, improved durability under extreme temperatures. Automakers such as Toyota Motor Corporation have invested heavily in solid-state research, aiming to deploy commercially viable systems within the next few years. When integrated into electric trucks and SUVs, solid-state platforms could redefine towing range, cold weather performance, and long-distance travel feasibility. 57. Active aerodynamic body systems. Aerodynamics significantly influence fuel efficiency and EV range. Active aerodynamic systems dynamically adjust body components in response to speed and airflow. Components include adjustable front air dams, deployable rear spoilers, active grille shutters, underbody airflow flaps. At highway speeds, these systems reduce drag coefficient. During braking, spoilers can deploy as air brakes to increase downforce. High-performance vehicles, including models like the Porsche 911 Turbo, have used active aerodynamics for years, but similar concepts are increasingly appearing in mainstream vehicles. 58. Smart glass electrochromic windows. Electrochromic glass can electronically adjust tint levels without mechanical shades. Functional advantages. Heat rejection during peak sunlight. Glare reduction. Enhanced privacy. Reduced HVAC load. By dynamically controlling solar gain, smart glass improves energy efficiency, especially critical for EVs where climate control impacts range. Some panoramic roof systems now integrate electrochromic dimming activated via touchscreen controls. 59. Vehicle health blockchain data systems. Vehicle service history is traditionally fragmented across dealerships and private mechanics. Blockchain-based vehicle health systems aim to create tamper-resistant digital maintenance records. Key benefits: transparent service logs, verified mileage data, reduced odometer fraud, improved resale value authentication. Fleet operators benefit from immutable maintenance documentation that reduces compliance disputes and warranty ambiguity. 60. Autonomous parking and self-return systems. Autonomous parking has progressed beyond basic parallel parking assistance. Advanced systems allow vehicles to drop off passengers, drive themselves to parking spaces, navigate multi-level garages, return to pickup points when summoned. Using ultrasonic sensors, LiDAR, 360 degrees cameras, AI mapping software. Luxury EV platforms, including vehicles from Tesla Inc., continue refining remote summon features. In dense urban centers, fully autonomous valet parking could become standard infrastructure. 61. Intelligent load monitoring for pickup trucks. Pickup trucks frequently operate under variable payload conditions. Smart load monitoring systems use Bed integrated weight sensors, suspension deflection measurement, real-time load distribution analysis. These systems provide overload warnings, axle imbalance alerts, towing tongue weight validation. In heavy-duty platforms like the Chevrolet Silverado 2500 HD, digital load monitoring enhances safety and regulatory compliance. 62. Augmented reality windshield navigation. Augmented reality (AR) navigation overlays directional prompts directly onto the windshield view. Capabilities: lane level navigation arrows, hazard highlights, distance markers, turn anticipation visuals. AR systems reduce cognitive load by aligning digital information with real-world road positioning. Unlike traditional HUD projections, AR windshields adapt dynamically to vehicle speed and steering angle. 63. Smart cabin zonal climate control with biometric feedback. Advanced climate systems now integrate seat occupancy detection, individual temperature zones, biometric sensors, heart rate, skin temperature. The system adjusts airflow and temperature automatically based on occupant comfort metrics. This reduces unnecessary energy consumption and enhances long-distance comfort. 64. Modular battery swap platforms. Battery swapping presents an alternative to fast charging. Instead of waiting, drivers exchange depleted battery packs for fully charged units. Operational model: robotic undercarriage battery removal, replacement with charged module. Process time 3-5 minutes. Companies like NIO have implemented battery swap networks in select regions. While infrastructure-intensive, battery swap systems may reduce charging congestion in urban environments. 65. Smart impact-absorbing bumper systems. Next-generation bumper systems incorporate energy-absorbing materials such as expanded polypropylene, aluminum honeycomb cores, composite fiber reinforcement. Sensors embedded within bumper assemblies can assess collision severity in real time and trigger selective airbag deployment strategies. 66. Intelligent tire compound monitoring. Tire performance degrades not only through pressure loss but also compound aging. Smart sensors embedded in tire sidewalls measure rubber elasticity, heat cycles, wear distribution. Data syncs to vehicle systems to recommend tire replacement timing. This technology is being explored in collaboration with manufacturers like Michelin. 67. Vehicle exterior self-healing paint coatings. Self-healing paint uses elastomeric clear coats that reflow under heat exposure. Damage recovery mechanism. Minor scratches activate polymer realignment. Heat from sunlight or warm water triggers repair. Surface restores smooth finish. This reduces cosmetic maintenance costs and preserves resale value. 68. Emergency vehicle-to-vehicle (V2V) communication systems. Vehicle-to-vehicle communication enables cars to share sudden braking alerts, collision detection, hazardous road condition data, intersection approach warnings. Using dedicated short-range communication (DSRC) or 5G networks, vehicles warn each other milliseconds before visual confirmation. This technology is foundational to autonomous mobility ecosystems. 69. Smart trailer reverse assist systems. Backing a trailer requires counterintuitive steering inputs. Smart reverse assist systems allow drivers to turn a dashboard knob in the desired trailer direction, let the vehicle automatically control steering. Integrated camera guidance ensures precise maneuvering in tight spaces. Popularized in trucks like the Ford F-150, reverse assist reduces trailer-related accidents. 70. Adaptive noise cancellation cabin systems. Using microphones and inverse sound wave emission, active noise cancellation systems reduce engine noise, road vibration, wind turbulence. Electric vehicles benefit particularly due to the absence of engine masking noise. Microphones detect frequency patterns and speakers emit counterphase sound waves to neutralize disturbance. Concluding strategic analysis. Across these additional innovations, several macro trends emerge. 1. Energy decentralization. Vehicles are becoming mobile energy storage hubs capable of powering homes, tools, and infrastructure. 2. Digital integration. AI-driven analytics, predictive modeling, and cloud connectivity are transforming vehicles into data-centric platforms. 3. Safety automation. From driver monitoring to V2V communication, proactive risk mitigation is replacing reactive response. 4. Material science advancements. Self-healing coatings, lightweight composites, and solid-state batteries are redefining durability and performance. 5. Human-centered design. Ergonomic improvements, AR navigation, biometric climate control, and intelligent towing systems reduce cognitive strain. The modern automobile is no longer defined by horsepower alone. It is an integrated mobility ecosystem combining mechanical engineering, electrical architecture, digital intelligence, and environmental sustainability. As the industry advances, vehicles will continue evolving into adaptive, energy-aware, self-monitoring platforms capable of interacting dynamically with infrastructure, grids, and other vehicles. The next era of automotive innovation will not merely enhance transportation. It will fundamentally reshape how mobility interacts with daily life, urban planning, and global energy systems.